Hello there, Wildcats. Welcome to your geometry class. In this video, we'll be learning about similarity transformations and proving triangles similar. And our objective for the first part will be we have to understand that the two figures are similar if there is a similarity transformation that maps one figure to another. And then we will identify the combination of rigid motions and dilation that maps the figure to a similar figure. And we have to identify coordinates of the image under a similarity transformation. We already discussed about rigid motions. So what are the examples of rigid motions? We have your rotation, we have your deflection, and we also have your translation. So the essential understanding in lesson 7-2 is that a similar transformation is a dilation combined with one or more rigid motions. In order for two figures to be similar, there must be a similarity transformation that maps one figure to all. All circles are also similars. Okay. All right. So we'll just be using the same vocabulary. We have dilation, reflection, rotations, and translation. Okay. And our new vocabulary is similarity transformation. And then for 7-3, our objective is we have to use dilation and rigid motion to prove triangles are similar. We'll be using proportions and so on and so forth. Use angle, SSS, and SAS to prove triangles are similar. So our focus essential understanding is that two triangles are similar if, and only if, a composition of the rigid motion and a dilation will map the triangle onto another. Two pairs of congruent angles and three pairs of sides with length that are in the same proportion, okay? Or two pairs of the sides having congruent, including angles with length that are in the same proportion, are sufficient to show that the two triangles are similar. All right, so that is our objective and essential understanding for this topic in this video. Let's jump into our first example. Graph the composition of rigid motion in a dilation. If a line M is represented by the equation x is equal to -3, what is the graph of the image after a reflection with a line of reflection M composed of dilation of 0.5 or 1/2. So as what I've as just a review, if we are doing a composition, you have to start with perform first your dilation before we go to your reflection with the line of reflection M. Okay, so take note. There is a common error that we need to be careful of. So you need to be careful to use the correct center of dilation. When the notation does not specify the center of dilation, then the center of dilation is the origin. Now, in here, it was not specified that any center of dilation. Then we have to assume that the center of dilation is at the center or at the origin, which is 0 and 0. Okay, so we have to dilate this image. Okay, when k, okay, k here is equal to 0.5 or 1/2. So you have to multiply so that your c prime, so or a prime first, will be 2 times 1/2, that is 1. And then 4 times 1/2 will be 2. My b prime is -2 times 1/2 is -1. And I have 8 times 1/2 is 4. C prime, that is 0. 0 times 1/2 is 0. Then 10 times 1/2 is 5. And then this is now the dilated image. So I'm going to graph that. So I have 1, 2. Okay, 1, 2. And then this is my A prime. And then I have B prime is -1, +4. This is my B prime. And then my C prime would be 0 and then 5. So this is my C prime. I'm going to connect those through there. So give me a second here while I connect those. So this is now the dilated, okay, dilated image. Then, of course, we'll not stop there, and then we'll do reflection. Take note that there is a line of reflection wherein your x is equal to -3. So I'll just want to specify that and draw a line. Maybe I'll just draw a line here about the line of reflection. Maybe I'll just use blue color. So it says there that x is equal to -3. That's the m. It's here. So from there, this is the line of reflection. So that will be your line M. That is our line M. And we have to reflect that. So I'll just use green color. So we have to reflect. So A is 1, 2, 3, 4 units away from our line of reflection. So 1, 2, 3, 4. That is now your A double prime. Your B, it's 1 and 2 from the line of reflection. So 1 and 2. This is now my B prime, double prime. C, it's 1, 2, 3. 1, 2, 3. This is now my C prime, double prime, sorry. All right, and then I can now connect this 3. Just change that. Then change color to green. So from C double prime to B double prime, and from A double prime to B double prime, from A double prime to C double prime. There you go. So the final image that we have there is the green in color. So let's do a conclusion on this one. So the conclusion is that the graph of the image of the reflection composed of the dilation, which K is equal to 1/2 of ABC, is now triangle A double prime, B double prime, and C double prime. Remember our common error there, okay? If your center of dilation is not mentioned, it's automatic. The center of dilation is at the origin or at 0, 0. All right, another example here is what are the vertices. So we are looking at the vertices, so meaning we need the point. So dilation 1.5, and then composition, the reflection from y-axis. So first is reflection to y-axis. I'm going to graph this. So my A is at 5, 4, -5, 4. I'll just graph it here. This is my A. And then my B would be 3, 5, positive 3, 5. This is my B. And my C would be 2, 1, 2, and 1. Okay, I'll just connect this one, guys, okay? So that is the graph. Now, what I'm going to do is to reflect that in y-axis, and take note, my line of reflection is the y here. It's the y-axis. That's my line of reflection. So I'm going to use blue. So I'll start with A. So A is 1, 2, 3, 4, 5. 5 units away from my y. So 1, 2, 3, 4, 5. So this is now my A prime. My B prime, it's 1, 2, 3. So 1, 2, 3. So this is now my B prime. And my C prime, it's 1, 2. So 1 and 2. So this is my C prime. Now I'm going to connect the graph. All right, the blue graph is now the image after reflecting the pre-image along y-axis. Now we have to dilate that, okay? We have to dilate it using your center of dilation is at 0 and 0. So first is identify my A prime point, my B prime point, and my C prime point. And my K here is equal to 1.5. So my A is 5, 4. My B is negative 3, 5, negative 3, 5. And then my C is negative 2, positive 1. All right. Now I'm going to multiply each value of x and y in that ordered pair so that I'll have, maybe I'll just use the red color here so that I will have, a red color. So A double prime, B double prime, and C double prime. Right, there you go. So we have to multiply each. There you go. These are now the point of A double prime, B double prime, C double prime after I multiply each values of x and y on my ordered pair with my k, which is 1.5. Now let's plot it together. So A double prime is 7.5, 7.56. So 6, 7.5 at the middle. This is now my A double prime. So my B double prime will be negative 4.5. So 4, 5, 4.5. Wait, I'll just take a look at this one. So 7, 7.5, that's right. So I have 4, 4.5. It's here at the middle. Then positive 7.5, 6, 7, 7.5. It's here. So this will be my B double prime. And then my C is negative 3, and then 1.5, 1, and then 0.5 here. So this is my C double prime. So I'll just connect those points that I have using red color. There. I'll just connect that. Okay, guys. So what are the vertices now? So the vertices, to answer the question, it's here. A prime has 7.56 and B prime is negative 4.5 and 7.5. C is negative 3, 1.5. Okay, so this is the image, how it looks like. All right. Okay, another example. I'm going to map this again. So I have C is 2, 1. And I think it's the same. I'll just use a blue color here, 2, 1. So this is our C. And then we have 3, 5, 3, and then 5, 3, 5. We have B. And then we have our A is at 5 or 6, 4. So we have negative 6, positive 4. This is my A, and then I'm going to connect those points that we have there. So from here, I need to use blue color. I'm just connecting these points, guys, so you will see the triangle. So this is your pre-image. Okay. Now, first is we have to dilate because that's the composition. So we have to dilate that at the center. Identify your A. A is at negative 6, negative 6, 4. And then we have B is we have 3, 3, 5. And then we have C is 2, 1. Okay, so I'm going to dilate that, meaning this will be my A prime. So I'll just use red or green, sorry. I have to use green. So my K here is equal to 3, so I'm going to multiply that. So A prime will be negative 6, 12, 18. Okay, negative 18. So we have now your A prime, B prime, and C prime after we multiply everything with 3. So I can now graph it. So I have, so your image now it's 3 times bigger. So I have negative, I'll just 10, 11, 12, 13, 14, 15, 16, 17, 18. So negative 18, 12, 10, 11, and 12. So it's here. Oh, it's a lot bigger, guys. So this is your A prime. And then B prime would be 9, 9, and then 15. So maybe it's here a lot bigger. Okay, B prime. And then your C prime is 6, and then 3. 6, 2, 3. And then this is my C prime. I'll just connect those so you can see how big it is. It's 3 times bigger. Okay, okay, there you go. It's 3 times bigger. Okay, now our image now, what are the vertices? So we are going to look at the red color here. So I'll just go red color. So we all know that we have A prime, it's 18, negative 18, and then 12. And then we also have B prime is 9 and then 15. And then C prime would be 6, negative 3. Now to get our double prime here, we have to apply the translation. A double prime, B double prime, and C double prime. So the translation is that your x is you subtract it with negative 4. So because it's negative, so you subtract it with negative 4. The meaning of this one will be 4 units to the left of the x-axis. And then this one will be, because it's negative, so down to your y-axis. So we have 18 minus 4, that is 18, 22. So negative 22. And then it's like negative 22. It goes to the left, right? 18, 19, 20, 21, 22, and go down. 12 minus 1, you go down 1 to 12. So 12 minus 1 is 11. And then your B prime will be 9 minus 4 would be 5. And then 15 minus 1 is 14. So it goes like this. So 18, 19, 20, 21, 22, and then you go down to 11. So this is my A double prime. And then B prime, it's from here. So it goes to the right because this one it's 9 minus 4, it goes to the left, it goes to 5, and then you go down 1. So this is my B double prime. And then my C is 6 minus 4, it's 2. And then negative 1 minus 3, or negative 3 minus 1, it's negative 4. So my B prime will be 2, negative 4. So 2, negative 4. So from C prime, it goes 4, 1, 2, 3, 4, 1. There you go. So 2, negative 4. Sorry about that mistake there. This one must be positive 3. So 3 minus 1 will be 2. So you have this here, 2 and 2. So this is C double prime. And then I'm going to connect those points. At least I saw that. There you go. So connect those points here. So your image now will be the red one, the double prime. So after the rigid motion and the dilation that we have. All right, so to answer the question, what are the vertices after the composition. We have A prime, it's negative 20 to 11. B prime, A double prime is negative 20 to 11. B double prime is 5 and 14, and C double prime 2, 2. Okay, let's go to the next one. So we are going to verify triangle similarity. Now, just like proving two congruent triangle, we also have your angle. Once that you have two angles are congruent, then we can actually verify the similarity. We also have your your side similarity theorem. Now we have to verify using those, okay, as a foundation that we have. So we verify triangle similarity. We have our first example here, which is our triangle ABC and DEF. Are they similar? And then letter B is triangle PQS and triangle RQP are similar. So the only thing that we have to do here is we have to determine whether the ratio of the corresponding side length are equal. Take note, there are some common errors also. When setting up ratio, check if the triangles are similar. So when setting up a ratio to check the triangles are similar, be sure you place the side from the same triangle in the same position in each ratio. Okay? Now, in this, as we can see, you have to make sure that you know the corresponding sides of each triangle. So in my example here, the corresponding sides are AB. So I'll start here. AB corresponds to what side? It's DE. Okay, they are corresponding. So I'll put there AB because we are talking about ratio. So we have to make it a fraction. DE. Okay, then after that, what's the measurement? It's 3. What's the measurement of DE? It's 4.5. Which 3 divided by 4.5, it's 2/3. Okay, how about BC? This part here, B to C. So BC corresponds to what? FE or EB or EF, sorry. So EF. Thus, it will be 4 divided by 6, which is, again, it's 2/3. Now, do not interchange. If you start in the smaller one, you have to start with the smaller to everyone. So, of course, your AC. So we have AC over DF is equal now to 5 divided by 7.5, which is also equal to 2/3. All right, so the ratio are equal. So the corresponding side length are proportional. Take note, so the side lengths are proportional. Therefore, triangle A, BC, and triangle DEF. So take a look at this wavy here in the middle. So if you put that, that's a symbol for similarity by SSS. SSS because everything you use is the proportion on the side. Okay, how about letter B? So my letter B, it says there that what our triangle PQS and RQP similar. So there are two triangles here. So one is the bigger one and then another one is the smaller. Okay, and we're going to remove or to draw your SPQ or PQS, your PQS. So I'm going to draw that. So triangle, I'll just draw it like this one. So this is P, this is Q, which is the bigger one, and this is S. Okay, so which is PQ is 18 already, and then your SQ, it's 15 plus 12, that's 27. So I'll just draw a red one. The smaller one, it's this one. So I have, let's see if they are similar. So this one will be R. Let's say this is R, this is P, and this is Q. So I did, I flipped that. So I know that my RQ, it's this one, it's 12. And then my PQ, it's 18. PQ is 18, it's this one. Okay, so I'll just take a look at the if they are proportional. So first is identify the ratios. Okay, so corresponding parts. First is SQ over, so SQ over PQ. So that is SQ is 27 divided by 18. That is equal to 3 over 2. While PQ, PQ over RQ. So PQ and RQ, which is PQ is 18, and then this is 12, which is also 3 over 2. So therefore, the common ratio here is 3 over 2. I'll just erase. That's not negative, guys. So it's 3 over 2. So since we have the same, the sides are proportion, and the length of the sides that includes angle Q are proportional. Okay, look at angle Q because they it is common to them, and therefore it is proportional by SSS or SAS. So we can now say that your triangle PQS is similar to triangle RQP. Right, next example. So now we are going to find the length. So in these two triangles, what is the measurement of MN? So in this example, we have to find the measurement of MN, and we all know that this angle here are congruent. Okay, so angle JLK is congruent to angle MLN because they are vertical angles. So they are vertical angles. And the side that includes angle JLK and angle MLN are proportional. Therefore, okay, therefore by SAS, okay, by SAS, we have, by SAS similarity, triangle JLK is similar to triangle MLN. Okay, so we have to write the proportion using the corresponding sides and solve for MN because we know it already that by SSS they are similar. So we are going to use proportion, write the proportion using the corresponding side. So we have MN, your MN, this one MN here corresponds to JK, which is the measurement is 10. Okay, maybe I'll just write JK here. JK is equal to MN, wait, I'll just, yeah, the JK there is 10. Okay, is equal to 1 over 75. Okay, so is equal to 1 over 75 because 1 corresponds to 75, or ML corresponds to JL. So we do multiply cross product here, which is that is 75 MN is equal to 10, and then I'm going to divide both sides by 75 so that we have the measurement of MN is equal now to 2 over 15. So the measurement of MN is 2 over 15. That is how you find length. Okay, so we have to solve these problems involving similar triangle. The problem says that Avery puts up a radio antenna, and then a tower in his yard. Ella tells him that their city has a law limiting tower to 50 feet in height. How can Avery use the length of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? Right, so let's see how can we solve this. First is we have since I can write it here. Since angle BAC is congruent to angle SRT, okay, and we also have angle ACB is congruent also to angle RTS. Okay, so it's RTS and then ACB because they are 90 degrees. Okay, these are 90-degree angles. You can apply AA. So they are similar. The two triangles are similar by AA, similarity. Okay, so we can now write. So by AA similarity, triangle ACB is similar to triangle RTS. Now we have to make a using the corresponding sides of these two triangles that are proportional. We can now make our proportion. So we have ST corresponds to, where is ST? ST corresponds to BC. BC is equal now to BC, and we have RT corresponds to AC. So RT corresponds to AC. Because we are looking at the height of the tower ST, so that's unknown. So ST and then over BC, BC is 6 is equal now to RT, which is 40, over AC, which is 5. And then, of course, we cross multiply this too. So we have 5 ST. So 5 ST is equal now to 6 times 40 will give us, will give us 240. And then I'm going to divide both sides by 5, so that our ST is equal now to 48 feet. So ST is 48 feet. So we can now say that the antenna tower is 48 feet high. So Avery's tower is within the 50 feet limit. So it's still be within the 50 feet limit from the city. All right, so that is our lesson for similar triangles. So we'll see you in the next video, guys. If you have any questions, just let me know. Just email me or call me. Thank you, guys, and bye-bye.